Welcome back to episode 2 in our data structures subseries. We're going to start talking about data structures with the array. This is the most basic data structure of all the programming languages. Anyways, we have three types of arrays. We have the static array, dynamic array, and multi-dimensional array, also known as a matrix. Anyways, what is an array? Well, an array is just a series of memory blocks used to store a certain type of data. So in this example, you can see we're storing integer data, and we're storing multiple data points of integer type, of the integer type. So that's the whole point of a data structure, to hold multiple data points. And whether it be the same data type, that kind of depends on the programming language that you're using. I know in Python you can use some sort of data structure where you can store multiple data types. Anyways, we're going to start with the static array. So the thing with the static array, we talked about automatic allocation. It's like that. When you declare an array statically, it's going to be in memory until it either goes out of scope or the program finishes. So obviously this is going to lead to some memory issues where we're wasting memory and we don't have enough memory. That's where dynamic arrays will come into play. Anyways, the syntax for actually creating an array in different languages is a little different. So C++, we say data type and then the name of the array, and then you'll always see these square brackets. So that's consistent through most programming languages. And then in C++, we would put the size of the array in there. And then in Java, you can see it's different. We have the data type and then the square brackets, and then no size, but we have the name at the end. Arrays store data sequentially in memory. So let's take an example. We are creating an array called myArray. It's of type integer, and we create 4 slots. So what's going to happen here is when we actually create this array, when we're running the program, is we're going to find 4 slots in memory, and they have to be right next to each other. So an int is 4 bytes. So we have to find 4 times 4, which is 16 bytes that are sequential in memory. So when we're running a program, let's say that address 100 through 116 are free, so we're just going to use that for our myArray. With arrays, the most important part probably of this video is with arrays you can do what's called indexing. So when you're trying to access one of these elements, you can just say a number, like down here you can say myArray of 0. What that's going to do is it's going to basically go directly to a spot in the memory. And with other data structures, what you have to do is you have to go block by block by block, searching for specific data. But with arrays, you can just go straight to that spot. So that's one advantage of arrays. Anyways, you can see here how this actually works is the array, when you declare it, it basically holds the starting address. So if the array starts at address 100 in memory, when you actually try to access one of these indexes, and I probably should mention this, the actual index numbers start from 0 instead of 1. So instead of going 1 2 3 4, we go 0 1 2 3. So the maximum index number is always going to be 1 less than the size that you put in. So here we're saying, okay, I want to access my array at index 0. So what's going to happen is it's going to take that starting address of the array and add whatever data type you're using times that index. So you can see integer data type is 4 bytes. So we multiply that by the index 0, and obviously that just gets us address 100, and there it is, that's index 0. You can do this with any index that's obviously 1 less than the size you put in. Anyways, my array 2 would say, okay, 4 bytes times 2 is 8, plus 100 is 108. So I'm going to go straight here. And that's what indexing is, and that's how it works. And obviously that's going to be a little advantageous to other data structures in the way that it can just go straight to that index. And we'll see that when we look at other data structures. Okay, let's take another example. So we're creating a array called myArray of type integer, and it's of size 5. So anyways, this is going to find 5 slots in memory right next to each other. And the indexes, like I said, start from 0, so 0 1 2 3 4. And like I said, the max index is size -1, so 5 minus 1 is 4. So there are 2 different ways we can assign values to these spots. What we can do is we can go to the specific slot and then set the value. So you can see here, my array index 0, I want it to be 3. So what that would do is it'd go up here and then it would set the value equal to 3. And then for the other indexes here, index 1 is 4 and then index 2 is 1. So anyways, the other way we can do this is when we actually declare the array. In C++, if you declare it this way and you actually put the values in curly braces like this, basically what's going to happen is the compiler is going to look at how many numbers there are in the curly braces, and that's going to be how many slots you need. So you don't need to put a size in there. You can put a size in there, but it's not really necessary if you declare it with the actual values. So anyways, what this would do is it would basically read those values in the curly braces one by one and then assign them. So it would be like 1, 2, 3, 4, 5, like that. Okay, let's go ahead and look at some code. Okay, right now we're working in C++. I'll show this in Java too. So we're going to simply declare an array and we'll say of type int, and we'll go ahead and call it myArray like we've been doing. Then we'll put the curly braces and we'll put the size in there. One thing about this in C++ specifically is you can't do like this. You can't say a size variable and then set it equal to a number, and then you can't put the size in here. You can't do that. So it has to be a literal number. It has to be constant basically. So we put a number in there. Now we can do that with dynamic arrays, and we'll see that in the next video. Anyways, now we have an array of size 5. We can do it that way, or like I said, we can do it this way. So we put curly braces and then we put however many values we want. We could do even 6 if we wanted to. Anyways, I'm going to do it the other way. So we'll put the 5 in there. And now what we can do is we can go ahead and create a for loop. So we'll go ahead and do that. We'll put our counter as I, set it to 0 because we start counting at 0. Then we'll say while I is less than 5, and then we'll say I plus plus. Now what we can do is we can go ahead and set the values using this for loop. So we'll just say my array, and then we'll say at index I. So what this is going to do is it's going to go to whatever I is, and obviously we're going from 0, 1, 2, 3, 4. So that'll work because our array is has 5 slots. Anyways, we'll say is equal to, and then we'll just say I. So this will set it to whatever index it's at. And we'll go ahead and print. So we'll say cout, and we'll print out my array at I. So whatever it was just set at. So we'll go ahead and save this. And we'll go ahead and compile this here, main.cpp, and then we'll link it. So we'll say g++ o run me.exe and then main.o, and we'll go ahead and run it. And there you go, 0, 1, 2, 3, 4. Probably should have put a new line in there, but whatever. Anyways, that's how you do it in C++. For the Java version in Java, to actually declare an array, I'll just show you that. So the syntax again is the type and then the square brackets and then the name of the array, so like that. But they have made it so that anybody who has programmed in C or C++ can do it using that syntax. So you can say the name of the array and then the square brackets, so that's kind of neat. But as for the actual allocation of the memory for this array, in Java you do this dynamically. So we're going to save the Java implementation, or actually looking at the Java arrays, until the next video.
Perfect.